Hello everyone, I hope you are doing well. So in today's video, we are going to go through the 2024 VCE Specialist Maths Exam 1. I hope this video finds you well and helps you with your specialist studies. So for this exam, I'm going to try to go as much detail as I can, especially in the newer study design points such as lines, planes, proofs, and yeah. And just like always, guys, if you guys want private tutoring in specialist methods, physics, or chemistry, you can always email me through this email. Let's smash through this paper. So question 1. Consider the function with the rule f of z to be this, where z is a complex number. Verify that 3z plus 2i is a factor of f of z. So we know this is a factor, so we can write it as this. So if it's a factor, then the root of this factor, so when you let it equal to 0 and you solve for the root, which is basically negative 2i on 3, this root, if you sub it into the function, it must equal to 0. The function should equal to 0. Hence, then it will become, then this here expression is actually a factor. That's how we can prove it's a factor. So what we can do is, for it to be a factor, what we can do is, kind of rub all this out. All we have to do basically is sub in that negative 2i on 3, and hope that it's equal to 0. If it's equal to 0, then it's a factor. If it's not a factor. So let's do that. So it'll be 3 negative 2i on 3 to the power of 3 plus 2i negative 2i to the power of 3 all squared plus 3 negative 2i on 3 plus 2i. Perfect. All right. So let's expand. Okay, what's negative 2 to the power of 3? We'll know that's negative 8. And what's I to the power of 3? It's actually negative I. So this becomes positive I. So it'll be 8i at the top. And what's 3 to the power of 3? It's 27. 27. Now what's 3, they're going to do 27. It's actually 9 times. So we can write it as that. Simplifies that. Plus 2i. Same with this. What's negative 2 squared? It's positive 4. What's I squared? It's negative 1. So negative 1 times 4 is negative 4 over 3 squared is 9. Done. So what's 2i times negative 4? Negative 4 over 9. It's negative 8. Negative 8i on 9. And so these also cancel out. So it's just negative 2i plus 2i. And as you can see, these all cancel out. They all cancel out to make up, of course, 0. Hence, as f of negative 2i on 3 is equal to 0, then 3z plus 2i is a factor. Easy. Perfect. Next question, let's use a different color, this color. Hence or otherwise, solve the equation f of z equals 0. Give your answers in Cartesian form. So there's actually another easier way to do this question, because it's only specific for this question, but what you can do is, let's write it down. How can we solve this at a, if you don't go, there's a method called factorizing by grouping, if you haven't heard. And for this case, it actually works, and I'll show you how to do it. What we have to do is this. So how do we factorize this expression? What about if we split it into 2? So we split it into 2 sections. So just this is one section, and this is one section, yeah? And we take, factorize them separately. So what's the, when we factorize this here, what is it going to be? Well, you can see that there's z squared as a common factor, so it'll be 3z plus 2i, perfect. Plus, what's the factor here? Well, there's nothing, but imagine you take out a common factor of 1. So you can write it like that, plus 2i equals 0. Can you see how these two expressions are the same? So we can actually factorize them out. So let's do that. 3z plus 2i, z squared plus 1. And we can write this expression as, of course, z squared minus I squared equals 0. And now we can use differences of perfects of squares to factorize it. Let's do that. So 3z plus 2i, z minus I, and z plus I equals 0. Hence, your values are for z, when you're solving them, is negative 2i on 3, z is equal to I, and z is equal to negative I. Beautiful. Nice. Those are your questions. That looks all good. Next question. Plot the solutions of f of z equals 0 on the Argand diagram. Easy. So let's do that. Well, the first one are the easy ones, like negative I and I. So I is over here on the imaginary axis right over here. So that's z is equal to I. And z equals negative I is right over here. So we write z equals negative I. Z, negative 2 over 3i is basically over here. So it's 1, 2. So it's this one over here. So z is negative 2 I on 3. Is that right? Beautiful. Nice. That's it. Just plot those 3 points and done. Now we're up to question 2. Let's do this. Prove that if x is an odd integer, then this is even using direct proof. What a beautiful question. When I saw this question, when the paper came out, and while students were doing it, I was scared that the proof question could be hard. But when I saw this, I was so happy. Direct proof is one of the most nicest proofs to do. They're really fun and easy. So what we have to do is, it says let x be an odd integer. So let's make x an odd integer. So we can say let x be 2m plus 1. Where this is odd, where this always gives us odd numbers, where of course m is an element of all integers. Done. And what we can do is sub into this expression, hopefully prove it that it's even. And let's do that. So I'm going to write it down. So 2x squared minus 3x minus 7 is equal to, now subbing for all the x values, we're going to sub in this. So 2m plus 1 squared minus 3, 2m plus 1 minus 7. Now we're just going to expand it. That'll be 4m squared plus 2, 2m, 1 plus 1, minus 6m. Just try to expand this. Minus 3, minus 7. So it'll be 8m squared. All right. Plus 8m plus 2. I want to make sure I haven't made any mistake. Perfect. Minus 6m minus 10 is equal to 8m squared plus 2m minus 8. That looks right. And as you can see, we can actually take 2 as a common factor. So let's take 2 as a common factor. So it'll be 4m squared plus m minus 4. And because we know this is an integer, because remember that m is all integer values. And of course, if you square integer values, they're just going to be also integers. And yeah, everything's all integers. So we can say, we can make all this expression over here. So we can say, let's say let I be this whole expression here. So it becomes easier to visualize. 4m squared plus m minus 4. So we can rewrite this whole expression as 2i. And remember, this is actually even. So 2 times this here is even. Hence we can say, hence when x is odd, then 2x squared minus 3x minus 7 is even. Easy proof. How many marks? 3 marks. A really nice, easy 3 marks there. Question 3. Let f be all reals except negative 1, where f of x is this. Okay, beautiful. The rule for f of x can be written in this form, where a and b and c are all integers. Show that a equals that, b equals that, and c equals that. Really, really nice question. So what I'm going to do is first I'm going to kind of write f of x in its expanded form here. F of x is equal to x squared minus 2x plus 1, of course, for the top one, and x squared plus 2x plus 1. Beautiful. Now I know that, this divides. We know that. So we can actually just use long division, quick. So use long division. So x squared minus 2x plus 1 is being divided by x squared plus 2x plus 1. And so 1 is our divisor. So 1, it'll be x squared. You multiply by that is plus 2x. And that divided by that is plus 1. Hence we get, okay, minusing them, these cancel out. When you minus them, this you'll get negative 4x, yeah? Because negative 2x minus 2x, yep. And then these cancel out. So we're left out with this. This is your actual remainder. So we can rewrite this whole thing. We can write f of x as 1 plus this remainder over your denominator, which is that. We can actually write this denominator as just the factored form. It's so much easier. So x plus 1 squared. So we've already made some progress. We already know that a value is 1, and it shows here. Now we just need to use partial fractions to simplify this expression over here. And that's quite easy. Let's do that. Let me put this at the top. I know that, like, negative 4x over x plus 1 squared will be, partially, when you're doing partial fraction, it'll look like this. This will be x plus 1 squared and plus b, which is going to be basically just x plus 1. And so simplifying this will be negative 4x is equal to what? A plus b x plus 1. And so if I imagine when I sub in x equals that, let's sub in x equals negative 1. Why? Because if I sub it, this will be 0. Yeah? So, and if you sub it here, it will be positive 4. So it'll be 4. It's equal to a. Your a value equals 4. So what I can do here is I can substitute 4 here. So that's what it simplifies to. Let's also find b. Well, b is easy. Just imagine expanding it. The whole expression, this whole expression here. A plus bx plus b. And I know, like, there's 0 here. So the coefficients, at the left-hand side is 0. And the coefficient c, it's a plus b. Which is, how we know a is 4. So we can actually just sub in 4 here. So minus 4. So b is going to be minus 4, basically. And so what we can do is we can sub in negative 4 here. Done. So we've kind of shown everything, like small proof. So we've kind of got everything. And so now we can write overall f of x. Now, overall f of x, which is, 1 plus 4. Wait, do that? Yep. So they started with this one first. So plus negative 4 over x plus 1 plus 4 x plus 1 squared. And that actually looks the same as our one. As you can see, our a value is 1, b is negative 4, and c is 4. Beautiful. Done. For 1 mark. That's really nice. The graph of f has one turning point. Find the coordinates of this turning point. Easy. So we know that, let's write f of x first. So f of x was what? Just did a non-expanded form. Just x minus 1 squared over x plus 1 squared. Is that right? Yep. And so we're going to use here, of course, we need to derive and let it equal 0. That's how you find turning points. And let's do that. We have to use the quotient rule here. So that's u and that's v. So f dash of x is what? So it's going to be v first. It's v, so x plus 1 squared, times u dash. So how to derive this? We're just going to use the turn rule. So bring the 2 in there, derive the inside, which is just 1, rewrite it to new power like that. Then don't forget the minus, and it's going to be u, x minus 1 squared, times your v dash, which is bring the 2 in there, derive the inside, rewrite it to the new power. There it is. We're making good progress here. And then, of course, v squared. So v to the power 4. All right. So let's expand this more. Like, not expand it, but simplify everything at the top. So it'll be 2 x minus 1 x plus 1 squared minus 2 x plus 1 x minus 1 squared all over x plus 1 to the power 4. As you can see at the top, there's a common factor of x plus 1 we can take out. So it'll be 2 x plus 1 x minus 1 x plus 1 minus x minus 1 squared. Is that right? I just want to make sure I haven't made any mistakes. Okay, that looks good. All being divided by x plus 1 to the power 4. And we can actually cancel this top part here with, and this becomes a 3 here. So then there's a 2 here. Done. All right, so now what I'm going to do, so why did that happen? What I'm going to do is put it here. Now, of course, you're letting f dash of x be equal to 0 overall. Remember, we're trying to find turning points. So if you let it equal to 0, you imagine multiplying the bottom part by 0. It just gets out, like, oops, that just drops out. And you're left out with this now. Now, of course, you know, the 2 is useless to just cancel out, and you're left out with this here. That's equal to 0. What is the common factor we can see now? Of course, it's just x minus 1 is a common factor. So what's happening there? So take x minus 1 as a common factor, and you're left out with x plus 1 minus x minus 1 equals 0. So x minus 1, and then simplifying that, it'll be x plus 1 minus x plus 1, which is, you know, the x's cancel, it's just a 2. So it's just basically this. 2 equals 0. Hence, x equals 1. And that's why you have one turning point. So remember, we're trying to find the coordinate, so it's going to be what? It's going to be 1 dot, and we just need to sub it back to f of x, which is, what's f of 1? I mean, you sub it at the top, 1 minus 1, 0, so it's just basically overall 0. So that is your coordinate of that turning point. Easy. Next question. Sketch a graph of f of x on the set of axes below. Label all the asymptotes with the equations and the axial intercepts with the coordinates. Easy. So, first, the asymptotes are the easiest one. Remember, there is an actual y asymptote, which is 1, y equals 1, so let's do that. All right, let me just draw it nicely. Y equals 1 asymptote. And there was also a vertical asymptote, which was over here, which is solving the denominator equals 0, it's x equals negative 1. All right. Done. Now, the most easiest is we found the turning point, which is 1, 0, so it's over here, the turning point. Let's find the y intercept, which is just subbing 0 into f of x. So if you sub in 0, it'll be negative 1 squared, which is positive 0. It's just 1. So it'll be 0, 1, which is in the so it's actually crossing the asymptote. Remember, some can actually cross the asymptote. All right. So I just want to wonder, because if you're starting here, would it go like that? We just need to double check. I'll just sub in, that's negative half. Let's check what value that will give us. If I sub in negative half into this. So negative half minus 1 is negative 3 on 2, and you square that, it will be positive 9 on 4. Divided by, like, you know, negative half plus 1 is basically half, and you square that, it's 1 on 4. It's just, yeah, this becomes 9. So it's actually growing larger. That's great. So it means it actually goes up like that. Draw that nicely. It goes up. All right. And I know that this, of course, crosses, so it has to go like that. But I wonder, does it like go like this, or does it go like this, or, you know, it basically goes like that? We don't know. So what we want to do is, what happens as we approach infinity, to positive infinity, of course. We can double check that by subbing it in, actually, into the function. Don't sub it into this one because it's so hard to understand, but actually sub it into this, because you know that's still f of x. It makes it so much easier. So if you sub in infinity, infinity plus 1 is just infinity. So what's negative 4 divided by infinity? If you're dividing by infinity, it's going to be approaching 0. So imagine like negative 4 divided by infinity. It gets so close to 0, so we approximate it to be 0. So imagine that becomes a 0. And the same with this one, like infinity plus 1. It's just infinity, and then you're squaring it. Infinity squared, yeah, it's going larger to 0. So basically 0 plus 0, and then don't forget that 1. So it's actually approaching 1 overall. So it's actually going to go like this. In other words, it's going to go like that. That looks nice. What about the left-hand side? Well, let's just sub in negative 2 to check what happens. Is it like, does it start here or here? We have no idea. So if I sub in negative 2, sub in here, this one looks easier. So negative 2 minus 1 is negative 3, and you square it, it's 9. Then negative 2, that would be 1 squared, it'll be 9. So it's actually so high. So it's so high. So okay, so it starts somewhere here. What about if I sub in negative 4? Because I just want to make sure. Okay, negative 4. Negative 4 minus 1 is negative 5, and you square that, it's 25. Negative 4 will be 9. So 9, 18, 20. So it's around 2.5, you would say. So negative 4, 2, we'll approximate it to be here, somewhere here. And we know it grows larger like that. So it looks like that. Now, I'm not too sure. Like, does it, we know it goes like that, but what about here? Does it approach the asymptote? We can check it by just subbing negative infinity. What happens when it approaches negative infinity? Does it approach y equals 1? We can do that. All right, again, same thing. So if you subbed in negative infinity, so like overall, so let's do it. 1 minus 4 over negative, 1, 1 plus negative infinity is just going to be negative infinity. Negative makes a positive, so 4 divided by infinity is just 0. It approaches 0. It's very small. And same with this. So it's actually, yeah, it approaches 1. So you can actually just assume it goes like that. That's just a rough sketch, but not close. It's not the actual, yeah, something like that. That's not nice. I want to make sure it's smoother. Like that. Yeah, that looks like a little bit, maybe bend it. Something like that. That looks much more nicer. And yeah, we don't forget, we label the asymptotes. The actual intercepts, of course, this one was 1, 0. That's 0, 1. All right. With the actual intercepts of the coordinates. That looks correct. Done. Okay. Question 4. Consider the vectors A, B, and C where n is an element of integers. Find the angle between A and B. Easy. Just use the scalar product. So we know that A dot B is, of course, equal to the magnitude of A times the magnitude of B times cosine theta. So let's find A dot B first, which is multiplying 3j plus 3k dot B, which is 2i minus j minus 2k. So basically what's 3 times, there's no I component, so that's 0. 3 times negative 1, it's negative 3. So negative 3, and 3 times negative 2 is negative 6. Will give us negative. Aha, be careful. Can you see how our dot product is negative? So let me write it here. Can you see how our A dot B is less than 0? It, if you know, basically tells me about my angle is an obtuse angle, where the angle is between pi on 2 to pi. If your A dot B, so your dot product is positive, so greater than 0, then it's an acute angle. So pi on 2 and 0. Because it's negative, we know it's an obtuse angle, so just be careful with the, they might trick you here. So let's rub that out and just keep that in case. Let's find, of course, the magnitude of A, which is just square root of, what's 9? 9 plus 3 squared is 9, which is root 18, which is 9 times 2, so it'll be 3 root 2. Let's find the magnitude of B. Square root of 2 squared is 4, plus 1, and 2 squared is 4, it'll be 3. All right, so putting it all in our formula, we get negative 9 is equal to 3 times 3, so it'll be 9 root 2 cosine theta, where it's basically negative 1 over, let me write it nicely. Why is this moving, huh? Okay, so cosine theta would be negative 1 over root 2. And what's our base angle? It's pi on 4. But remember, it's an obtuse angle, so we know that theta is going to be pi minus pi on 4, which is 3 pi on 4. That's it. That's not bad. That's actually not bad. Nothing too bad right now, so this is looking positive overall. Okay, next question. Find all possible values of n, such as the dot product of A and C is equal to the magnitude of the cross product of A and C. All right, so what we're trying to find here is that the dot product, so A dot C is equal to the magnitude of the cross product, which is like that. Okay, so let's find first the dot product. So what's our A again? A is 3j plus 3k. Dot, and C is an I plus 2j plus k. So what I'm going to do is, of course, dot product easy. So, you know, basically, because there's no I component in here, it's just going to be 3 times 2, which is 6. And 1 times 3 is plus 3. Is equal to 9. So, okay. Let's also find the cross product first, which is basically, remember, so you have the I here, j here, you have the k. So it's A. What's A? A is, because there's I 0, it'll be 3, 3. Let me write it nicely. 3, 3. And the, you know, C is n 2, 1. Close it down, and that simplifies to what? So you can use actually your formula sheet. So let's go down. What does that simplify? On the cross product. Here it is. Nice. So it simplifies to, so y1 times z1. So y1 times z2, which is 3 times 1, which is 3, minus y2 times z1. So y2 times z1, which is 2 times z, that'll be 6. And that's I plus, so x2 times z1. So x2 times z1, so it'd be 3n minus x1 times z1. So x1 times, sorry, z2, which is 0. So this here is just basically j. Next one, plus, next one is x1 times y1. So x1 times y2, which is, 0, also that's 0, minus x2, y1. x2 and y1, so it'll be 3n. That'll be okay. Done. So, okay, we kind of simplify that. Simplify it. So it'll be negative 3i plus 3nj minus 3nk. Done. So we've got the cross product. We just need to find the magnitude. So easy. So the magnitude of that is the square root. So 3 squared is 9, of course. 3n squared is just 9n squared. And the same with this one. 9n squared. Okay. So that simplifies to what? Just as a hint, that'll be just 18n squared anyway. You can take 9 out, so it'll be 3 square root of 2n squared. Yep, because that perfectly works. And so now equating them, so 9, your dot product equals your cross product. So square root of plus 2n squared. Divide both sides by 3. This will be a 3 here. So then squaring it is actually just becoming a 9. The minusing 1 on both sides of this will be an 8. Rub that out. And dividing by 2, this will be a 4. So n is equal to plus or negative 2. Yeah, let's just find all possible values of n. Damn it. Yeah, that's just a lot of work, but that looks easy. Not too bad. Okay, next question. Question 5. The curve for the equation where you're going from 1 to k on 2, where k is greater than 2, is rotated about the x-axis to form a solid revolution that has a volume this. Show that k satisfies this equation. Okay, not bad. They've given us everything that we need to do. So we know that the volume, oops, that's the wrong thing. We know that the volume is pi integral. Where are we rotating? Well, we're rotating about the x-axis, so we have to write dx here, and the inside will be y squared. So when this gets squared, it's just basically the square root just disappears. So it'll be k minus x squared to the negative 2. Bring that to the top, yep. And then we're going from 1 to k on 2. So 1k on 2. Okay, that looks bad. That looks great. And of course, we know the volume is equal to 7 pi on 2. So we can just get rid of that. And we can actually get rid of the pi's on both sides anyway. So it's that. That just simplifies everything much more easier to. Okay. All right, now we have to integrate. Let's go. So that'll be kx here. That will be what? So it'll be negative x, and you add 1, negative 1 to negative 1. So it'll be plus 1 over x. We integrate that. And then from 1 to k on 2 is equal to 7 over 2. All right. So k on 2, like if you're subbing k on 2 on that is what? So k on 2 plus k on 2 will be 2 over k. Then don't forget the minus. And then when you start subbing 1 and stuff, so plus 1, close it all, equals 7 on 2. So it'll be overall k squared on 2 plus 2 over k minus 1. And bring that, now leave that 7 over 2 there. So, okay, what we want to do is get them all in the common denominator. So we can actually just multiply the lowest common denominator is 2k. So this, 2k times this will be, this 2, so it'll be k to the power 3. Let me drop that out. K to the power 3 for this one. The same with this one. This will be but plus 4. Yeah. This one will be minus 2k squared. Then 2k to this one, multiply 2k, will be minus 2k. And then 2k to this one will be just 7k. Because if you multiply 2k, these two cancel out. Okay. I hope I haven't made a mistake. Yeah. So k to the power 3, bring them all to the left. So that'll be basically minus 9k plus 4 equals 0. Is that the same? Yep, looks all good. That's actually not a hard question, but that's a nice question. For 3 marks, it's easy. 3 mark there. Okay, next question. Okay, probability. Let's get into it. So the production of a brand of weed trimmer involves 3 stages: stage 1, stage 2, and stage 3, which take W1 hours, W2, W3. Okay, respectively. Here's W1, W2. Okay, are independent random variables, which may be assumed to be normally distributed. Assume that stage 2 starts immediately after stage 1 ends, and the stage 3. Okay, makes sense. Okay, the mean standard deviation costs at each stage are shown. Okay, so stage 1, and we know that it's written as W1. That's the mean hours, or the average hours and standard deviation, and the cost per hour. All right, not bad for all. So what's the first question? Find the mean and the variance of the total time to produce one weed trimmer. Okay, so we're looking at time here. So the total time, so we can say, because W is time in this case, can you see that's time? So W time, let me write it nicely. W time, so the total time is what? Well, it's the addition of all of them. So like the first, the time where it's stage 1, then stage 2, and then stage 3. That will give you the total time. So we want to find the mean of that, and that's easy. Remember, the mean of the total is just the mean of the individuals. So it'll be 1 plus the mean of 2 plus the expected value of... Sorry, that was supposed to be a 3 here. Okay, which is what? So the expected value of W1 is what? It's 1 plus 1.5 for the other one, and 3 is 2. So that'll be 2, 3, 4, 4.5 hours. Beautiful. That's not bad. That's not bad. I can. This one's 4.5 hours. Let me write that down. So, oops. 4.5 hours. And remember, it's only 1 mark, so we just want the answers. We don't want too much working out. We're going to just rub them out when you do it. Okay, now we also need the variance. And we know the var of the total time is the var of each. Var of W1 plus var of W2 plus var of W3. So what's the variance of W1? So remember, you have this standard deviation here. So what we need to do is, that's 3 on 10 in terms of fraction. I'd like to deal with fractions than decimals, so much easier. So that's 4 on 10, that's 5 on 10. And of course, we're squaring them to get the standard deviation. So you know your standard deviation, you square it to get your variance. So this will be, so let me write var of W1 is what? It'll be 9 over 100. Var of W2 is 16 over 100. And the var of W3 is equal to 25 over 100. Easy. So we can kind of add them all up. So 9 over 100 plus 16 over 100 plus 25 over 100, which is, these two add up, they'll be 25 over 100 and adding up. So it'll be a half, basically. 0.5 hours. I want to make sure yeah, we just want the variance of the total time. So it's 0.5 hours. Just rub all this out. 0.5 hours. Beautiful. That's it. That should give you that 1 mark. All right, next question. It says then, find the variance of the total cost to produce one of those weed trimmers. Okay, now we're looking at cost. So, cost, the total cost. Well, so for per hour for W1, you know how that's per hour? This is the hours. Per hour, it costs $10. So if it's like, it'll be basically it'll be $10 for every W1. Does that make sense? So because you know how this represents hours, like hours, the time. And so 10 times that. Yep. Plus the same for the other ones. Plus, of course, 20 W2. Oop, what's this? So W2. And then the other one's 15. W3. Easy. So that's your total cost, because that's hours and that's per hour. So that should give you the cost. And of course, we're trying to find the variance. So we want to find the variance of C, which is the variance of 10 W1 plus the variance of 20 W2 plus the variance of 15 W3. Now remember, this gets squared, the coefficient in front, so 10 squared is 100. Var of W1. This will be 400, because this gets squared, so 400. Var of W2. And this one, 15 squared, is 225. 225. Variance of 3. And so it's going to be 100. What's the variance of W1? We already know it's 9 over 100, so we can write that there. plus 400. What's the variance of W2? We know it's 16 over 100. And 225, what's the variance of W3? It's 25 over 100, which is just a quarter. Is that right? Yeah, yep. We can cancel those out, so it'll be just 9. I mean, these zeros can cancel out, so it's 16 times 4, which is what? Just want to make sure there's no mistake. 6, 12, 18, 24, 24, 4, 5, 6, 64. Okay, plus 64 plus, basically that's 225 over 4, this fraction. Okay, we need to deal with, oh my god, so much work. Okay, 64 plus 9 is what? It's 73. Let me just write that out. 73. So 73 plus 225 over 4. So what's that? Plus 225 over 4. So first, what is 73 times 4? 4, 8, 12, 12. 7, 14, 21, 28, 28, 29, 292. So it'll be basically 292 plus 225 all over 4. Okay, which will give me that out. So what's 292? So we can write it as that plus 25, which is 512 plus 5, which is 517. So 517 over 4. That is your variance of your cost. Is that correct? So let me just double check everything, because I didn't. So if you had 2, it'll be 417. Yeah, 417. That looks good. That looks good. Okay, not bad. C. If a single Witrim is produced, find the probability that the time spent at stage 2 will be less than the time spent at stage 1. Give your answers correct to 2 decimal places. Using probability, okay, that where Z is a standard normal variable with a mean of 0 and standard deviation 1. A really typical question, actually, that comes up most of the times now. So what we're trying to find is the probability that we're looking at time here, so W's in this case, that the time spent at stage 2, which is W2, is less than W1. So what we have to do is we can rewrite it as like minus W on both sides. We can write it like that, less than 0, because we bring it to the other side. And making it easier for ourselves, let's just let make it easier. Let X be W2 minus W1, just for simplicity. So we can write it as X actually. Just X is less than 0, and we're using. That's what we're trying to find out. All right, it's actually quite hot here. Let's go. So we need to find the mean of X, which is the mean of this here. And of course, the mean of that is just the mean of W2 minus the mean of W1. What's the mean of W2? We already know what that is. It's basically 1.5 minus W1 is 0.5. So 0.5. So you can just kind of get rid of this whole thing. It's just 0.5. Okay, that's good. We're making progress. We also need to find the variance of X. So, because we need to find the standard deviation. So if we find the variance, we can square root that. So the variance is, of course, the variance of this and the variance of that. But this gets squared, so that negative just disappears. It'll be variance of W2 plus the variance of W1, which is what? It means just adding these two up, which is 25 over 100, which is 1 over 4. Okay, 1 over 4. Rub that out. 1 over 4. And of course, find the standard deviation of X. You take the square root out, which is a half. Beautiful. So we're making so much progress. Okay, we've got that. Now we can draw a normal distribution graph. Like that. Where this is, of course, X. Let's draw below it your standard normal distribution Z, where this is your mean. Okay, so we know the mean for our X1 is 0.5, and every one standard deviation is a half, so this will be 1, this will be 0. But for this one will be 1, it will be negative 1 here. So what we're trying to find, of course, was the probability that X is less than 0, so it's actually this part. So we're trying to find this probability here. That's what we're trying to find. But we know that the probability for Z from negative 1 to 1 is this probability here, from here to here, is 0.68. So if we 1 minus that, the addition of these two would be 0.32, and dividing that by 2, because they're symmetrical, we should get that. So what's basically 1 minus 0.68, which I think, so yeah, 0.32, and then divided by 2, we get 0.16, meaning that this over here is 0.16. Hence, this here is 0.16. That's it. To 2 decimal places. Not bad, actually. Really nice. Wow, it's just a typical question that comes up most of the time now. Not bad. Okay, question 7. Solve the differential equation this, expressing y as a function of x given that this. Okay, beautiful. Let's do it. So it's in terms of x and y, 100% we're going to have to use separation of variables. Before we do that, we need to make dy dx a subject. So let's do that. Dy dx is what? So, of course, you minus x on both sides, and then divided by 2y square root of x squared plus 1. Beautiful. And so what we need to do is, of course, we have to use separation of variables, so we can just first write it 1 over 2y like that. So we don't need that there, just to make it, because we want to separate the y and x's, all of them. Just makes our life easier. And so what we can do is now use separation of variables. So when we integrate, we have to reciprocate the 1, like this whole expression in terms of the y. So it'll be just 2y dy, and integral this whole thing here in terms of x. Okay, I need to actually make it a bit bigger. So it'll be negative x over x squared plus 1 dx. So integrating that is what he'll be 2y, so it'll be 2y squared over 2, which is just y squared, is equal to, now we have to integrate that. So let me just write it here and start just doing everything. So we have 100% we have to use substitution here. So it'll be negative x over x squared plus 1 dx. We're going to let u be the x squared plus 1. So, of course, your dx would be 1 over deriving this, which is just overall 2x du. Don't forget that du. So we can rewrite this as negative x over root u times 1 over 2x du. Okay, why is that du? We can get rid of these x, this x here, and this x now. Don't forget that too. Just bring that all that negative half here. Okay, and we can write that as u to the negative half du. Now we can integrate that. So it'll be negative half. So it'll be what's happening with my brain? Okay, so yeah, we're integrating. So you add 1, so it'll be half, and then divided by half. Wait, am I tweaking here? I don't know. I'm so confused now. What have I done to myself? It's so basic. So if I had like used 2u, you add 1 and divided by 2. Yeah, that makes sense. What's wrong with me? I don't know. It just happened to me. I just got a full on like mind block or somewhere. Okay, so yep, I add 1 and then divided by half, which will be 2u and the square root of u. Done. That's u to the power half. And these actually halves cancel out anyway, so we don't need these here. But don't forget that negative, of course. That negative means. Okay, so now we've got that. And of course, that is what's u again? U is x squared plus 1. So basically, we know that when we integrate this here, it will be basically negative square root x squared plus 1. All right. And don't forget that plus c. Do not forget about that. So, of course, we have to sub this initial condition to find our plus c, which is, what's negative 2 squared? It's positive 4. Negative square root of basically 1. Well, actually, yeah. When you sub in 0, yeah, it'll be just 1. Plus c, which is c equals 5. So we can rewrite it again. Negative x squared plus 1 plus 5. And then y is equal to plus 1 negative. Negative, oh, that's a lot. X squared plus 1 plus 5. And then we need to check which one's, is it plus 1 negative that square root. The way, it's so easy, because what you just need to do is, for example, if I sub in x equals 0, the y value should output negative 2 anyway. So if I sub in 0 here, think about it. If I sub in 0 here, it'll be just 1. Square root of 1 is 1. And then that'll be, negative 1. So what's 5 minus negative 1 will be positive 4. So overall, this will be like this. All this expression will be that. And don't forget that plus negative. Don't forget, what am I doing? And then, of course, the square root of 4 is 2. So you actually overall get this, of course. And then, but you just need to, but our one's negative 2. So we just have to take the negative part of it. So we don't care about that positive. So we can get rid of that positive. That's what your final answer is. So just don't forget that negative there. It's really easy because all you have to do, sub in this and make it sense. That's it. It's really nice, this one. All right, there it is. All right, next question. Consider a relation this where x and y are elements of real, so use implicit differentiation to show that. Okay, that's nice. Like, I've seen implicit differentiation has been, it's every time in every exam, so we need to derive everything. So it'll be x squared, y squared, and derive the expression here, so xy, and also derive ddx2. So when you're actually deriving this, we have to go, we have to use for both of these the product rule. So I'm just gonna let sorry, I just need to so u v, and that's u and v. So it'll be for this one, it'll be u, which is x squared. What's our v? Well, v dash means that you derive that, which will be 2y, but because it's in terms of y, we write dx, dy dx, plus then it'll be y squared. Then you derive this over here, which is just 2x. And it's in terms of x, so you don't have to write dy dx. Plus, now we have to do the same with this. So you start with u. You derive y, which is just 1, but because you derived it in terms of y, it's dy dx. Plus, there'll be y, then derive x, which is just 1. So you don't have to worry about writing that. And then the derivative of 2, which is a constant, is 0. Okay. Good progress. So we're just going to expand this out. All right. dy dx plus y equals 0. So I'm going to take dy dx as a, to make, of course, dy dx the subject. That's the goal, what we're aiming for. So it'll be 2y x squared plus x, and bring all the other ones to the other side. It'll be negative y minus 2xy squared. And then hence my dy dx is negative 2x y squared all over 2yx squared plus x. All right, it doesn't look the same, but let's take the common factors. What's the common factor at the top? It's just a y. Actually, take negative y out, actually. Yeah, negative y. Let's take that out. It'll be 1 plus 2x y all over, this one has a common factor of x, so we can say x, 2yx plus 1. And actually, these cancel out because they're the same thing. You can cancel those out, and hence you get negative y over x. That is some work to do, but it's not bad. It's actually not really. It's really nice. Next question. Find all points of the graph of this where the slope of the tangent is equal to negative 1. So basically, they're just telling you, hey, that dy dx, that dy dx is negative 1, yeah? So like, that's easy because we know dy dx is that. So we're just saying negative y over x is equal to negative 1. Make just y the subject. So you can make x the subject. So it'll be y equals what? Y equals x. So we've tried to find all the points where this is where the slope of the tangent equals negative. Yeah, so basically come back and put it into this function, this whole relation here. Let's do that. So it'll be x squared. So you know how saying y squared? Just make it, because you know how y equals x, so it'll be also x squared plus x, because y is x, so x equals 2. It'll be x to the power 4 plus x squared minus 2 equals 0. Bring it to that. Okay, so this one is basically like let u be x squared. So it'll be u squared plus u minus 2 equals 0. So u and u, 2 and 1. So minus 1 here, does that? Yep, that works. So it'll be u plus 2, u minus 1 equals 0. Hence u equals negative 2, and u equals 1. Because you remember going back, it was x squared. So sub that back in. Now this doesn't exist because you cannot have a, we're not dealing with complex numbers here. Because again, they told us that x and y are elements of all reals. So we can actually just reject that. Just put x in there. So it'll be just x is equal to plus or negative 1. Perfect. All right. So that's the x values. Of course, we want it in coordinates. So the first one is, you know how it's positive 1. Because y equals x is just, again, the 1, 1. And then, you know how the other one's negative 1? It'll be negative 1, 2. Because y is equal to x. That's it. That's really nice. All right. Question 9. A car is traveling along a straight, flat road. The velocity of the car and its position x meters are measured from the position on the road where x equals 0. Okay, perfect. The velocity v and the position x of the car are related by this expression, where x is between negative 15 to 15 and velocity is greater or equal to 0. The speed detection device is positioned to detect the speed of the car as it passes the position x equals 0. The speed limit on the road is 40 kilometers per hour, and the speed detection device will be activated if the car is traveling 10% or more above the speed limit. All right. Determine with evidence where the speed detection device will be activated. 1 mark. Easy. So, well, we know it's only activated when the car's going like 10% or more than the speed limit. We know the speed limit's 40. So, what's 40 times 10? So, oops. So, what's 40 times 10%? 10% is 1 on 10 anyway. So, it's actually just 4%. So, 4. So, if it goes, because it's going another extra 4, if it goes, so basically, so this is what's happening. If your velocity is greater or equal to 44, by the way, because it says 10%, so it can be, if the velocity is 44 or more than 44, the detection device will actually then detect. So we need to check if it detects it, because we know we just have to sub in x equals 0, because that's where it detects it into this function, find the velocity. Not bad, not bad. Okay, let's do that. So it'll be v squared equals 1600 plus 672 over pi. Our cos is just cos inverse, and if you sub in 0, it'll be 0. Okay, what's cos inverse of 0? I mean, I just basically would draw the cos graph, actually. Draw the cosine graph, it'll look like this. Where that's 1, that's negative 1. That's pi. It's pi on 2. So this here will be pi on 2. So you actually can cancel this one out. And then this is divided by 2, which will be what? It'll be 3, 3, 6, is that right? 3, 3, 6. So if you 6, 7, 2 divided by 2 is what? Yes, that works. Yeah. That makes sense. Yep. Just want to make sure my maths is, just take care of your maths, guys. It's just make sure you don't make silly mistakes. Yeah. Then that is equal to 1936. So 1936. 1936. Then of course you take the square root of it. Now look, I'm not taking the positive and negative because we know that velocity is greater. It's greater or equal to 0 anyway. So it's 1936. Now I'm not going to estimate what that is, but what I should do, making my life easier, is just look at this velocity. I'm going to find like the square, like I'm going to square 44, yeah? I'm going to square 44. If I square 44, yeah, and say, I don't know, let's say square root of 44 is like, I don't know, 1697. Because this is greater, it means it would have been detected. Does that make sense? I can do that so much. That is such a more safer method than try to estimate where, you know, what's the square root of that and then comparing. No, shouldn't do that. So what's the 44 squared? It's just 44 times 44. Just need to do the math. 4 times 4 is 16. 4 times 16, 17. 16, 17. Be 6. 30. Put a 1 here. 91. 1936. 1936. Ah, no. So V equals that. It's just the square root of 1936 is just 44. So it will be detected because remember we're saying velocity is greater or equal to 44. So it is equal to 44 kilometers per hour. Hence will be speed detection device detected or something. Yeah, detection will be activated. Will be activated. Overall, not bad. The question. Anything bad? Yeah, not bad, not bad. Okay, let me just rub that out. Okay, next question. Find the acceleration of the car in kilometers per hour when x is equal to 12. I'll give you an answer in this. Now, this is actually not bad because when I saw why would they give you as velocity squared, and then it just hit me. We know that acceleration is also given by this, where the derivative, so ddx of half v squared. Can you see that? Isn't that the same? Because we've got the v squared there. We just need to half it. So let's do that. So if we half this whole expression, so imagine multiplying a whole half here. Yeah. So what's a half of 1 1,600. It'll be just 800, of course. What's a half of this, basically? It'll be 336 pi cosine inverse. Okay, so this is what happens if you half it all. That looks right, does that? Yeah. Let me write that down. And then, okay, so, and then we need to derive it. That's our goal. So let me just write that all here. It'll be 800 plus 336 over pi cosine inverse x over 20. Okay. Now deriving, of course, deriving this is just 0 because it's a constant. Then deriving this is what? We know it's just going to be, because it's just it's a constant, just bring it to the front. And let's just derive this over here. Now to derive, it's really easy. It's in your data book, so you can just kind of follow what it is. Go to the derivatives. Here it is. So deriving this over here is over here. So it'll be just, okay, it'll be negative a, so it'll be negative half in this case, all over the square root 1 minus basically x on 20 all squared. That is it. Nice. So that was an easy derivative. And guess what? That we're nearly done, because now we've got the acceleration formula. All we have to do is sub in x equals 12, which is what? So let's look at the inside. So if I sub in 12, it'll be 12 first. It'll be 12 divided by 20, which will be basically 6 over 10, which is 3 over 5. Okay. And then you square it, which is 9 over 25, yeah? Then you're saying, well, minus it, it'll be 16 over 25. And then we're taking the square root of it, which will be 4 over 5. And then you're saying negative 1 over 20 divided by 4 over 5. So you remember how you can reciprocate that, so like that. That'll be 4 times. It'll be negative 1 over 16. So that'll be negative 1 over 16. Wow, that's just so much work. Negative 1 over 16. Okay, let me just rub all this out. This rubbish. So, okay. Alright, so, I'm going to just basically, so we can put that negative there. Look at that negative here. And basically we will write this as 16 pi like that. Of course, we're going to simplify it because, when they're even numbers. So how much is 336 divided by 16? Okay, well, the most easiest case is just to think of it like dividing them by 2, because they're both even. So what's 336 divided by 2? It'll be 1 here, 6, 8. So this will be what you can simplify as 168 over 8. And again, you can still simplify it more. Oh, it'll be 21. Yep. Because 8 goes into 16 twice and then once. So 21. So it'll be negative 21 pi. That is it. Of course, kilometers per squared. Okay, that is it. Oops. All right, we're making some good progress here. It's just kind of ugly algebra in this exam overall. Last question, yeah. Oh my god, this question over here. Let me just give you my opinion. When this paper came out and students were doing it while I was waiting, and when I remember when they posted the paper, some students posted the paper early as possible. And when I had a first look at it, I nearly put my hand through the computer. I was so angry. How disgusting of a question could they put this here? The school line distance. Now, 90% of students that I've heard from everyone, they put it in their, They put it in their bound reference. Because it would make sense. Like, it's screw lines. It's the most random formula ever. But when they put it in this one, like for exam 1, and it's not even in a formula sheet, it was just silly. Now, of course, you can, if students knew how to, like, where the formula was, like, if they could just make a scenario, understand where you get the formula, then you could do this question. True, you could do that, but it would take so long. So the best, the students who were able to do this were actually memorized every formula, which now I would absolutely tell you guys, memorize the formulas, memorize every formula, distance formula, distance between planes, distance, blah, 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 just everything, angle formula, you need to memorize them. This was such, like, distance formula, I would have understood it, but the shortest distance between school lines was like the last chapter of the Cambridge book. So it was just so random, and I just felt so bad when I saw it, like, as a last question, because I knew I knew so many students would get it wrong. No, they would not would get it wrong. They wouldn't know how to start it. Like, what are they going to do? They don't have the formula with them. And yeah, so I absolutely would get you guys if you were frustrated at that exam. Nothing to be worrying about. Most of the students got it wrong, and it's okay. But do not worry about it. Because I'm going to try to show you the proof. I want to show you how to get where we get the formula, and I want you to memorize this formula. It's so easy to memorize. So because I want to show you where we get the formula, I'm gonna try and make it very easy. So I've already made an extra video explaining how I get the formula. So that'll be right now. I'm gonna show you how we get the shortest distance between squiggly lines. Let's go. Hello everyone. So let's define what are squiggly lines. So basically squiggly lines are lines that are not parallel, while not also intersecting. They must be lines that both are not parallel and intersecting. So how can we visualize that? Well, it's really hard if you draw it into the 2D plane. So like if you have a paper, it's really hard to visualize that. But what about in the 3D plane? So let's look at it in the 3D plane. So let's look at this here. Imagine that this is a 3D plane over here, and you got these two planes. I'm using planes just to draw the lines on top of them so you can actually see. Say we have the first line that actually looks like this over here. Say we have this line over here that goes like this. Can you see this line here? Say we draw this line. Can you see how it's like on the plane? Yep. And let's say also we have another line that goes, yeah, can you see how I made them not parallel? Like this one goes this way, this one goes that way. So we've already hit this point over here. They must not also intersect. So if I took this plane, yeah, and I put it on top of this, then they're going to intersect. But if I put them slightly down like this, can you see what I've done? If I slightly put them down, so now there's actual some distance between these planes in terms of this, some distance. They're not intersecting. Like this one here, this line over here is above that line. And so then when they go forever, this will go forever this way, this will go forever that way. Because this one over here is on top of that line. And hence, that's basically, they will never intersect, and hence they are non-parallel. Meaning that they are skew lines. Okay, we kind of understood that, yeah? All right, so what's very important about skew lines is how do we find the distance, the shortest distance between skew lines? And let's have a look at that. So what we need to do first is to have a look at, if you actually don't know, say, you know how you get your variable A1 here, let's call this line, before we start, let's call this line L1, and let's call this line L2. And you know how there's a significant point that makes the line. We call that, for example, this one, let's say it's this dot here, and let's call it A1. And this point here, let's call it A2 here. All right. Now, because, what's the shortest distance between these two lines, you might wonder? Well, let's have a look at it using Desmos as our example. Here it is. Here we have this overall cool looks the same basically. And imagine that these lines, can you see? I draw them on top. So that line here, that's L1 and that's L2. The same thing that I've drawn on my iPad. Now, if you want to find the shortest distance between these two skew lines, well, guess what it is? Isn't it going to be the same? So for example, that line's there and that line's there. Can you see that the distance between any point on the line is from here to here? It's just the distance between these two planes. And it's all the same. Like if you pick this point to that point, the same. This point, this point. So it doesn't matter. It's just basically the distance between two planes that these skew lines are on top of each other, which is cool. So let's come back to the iPad. Now we know that, we can straight away just draw like this 3 dimensions. So I know for a fact, let's take A2 here, yeah? There's A2 over here. If I go vertically on top, yeah? If I just go vertically on top and then I touch the plane. So this is where I touch the plane, and then I go, actually let me go up a little bit more. And then I go horizontally right, and then I draw a right angle triangle, because it's a right angle triangle. Well, we know this is a right angle, because remember, this is where the plane is. I'm touching the plane. So now we've made a right angle triangle. Can you see how this is our distance between our planes? And remember what I said, that the distance between these skew lines is the same as the distance between those two planes that the lines lie within, as we saw. So we want to find this distance over here, this over here. How do we do that? Well, let's call this here, this angle here, let's call it theta. How do we find this here? Let's actually draw all this simply in here. Like that. That's the right angle triangle. That's A1. That's A2. That's your distances. That's what we want to find. And this is theta. How do we find this? We can easily find this distance because it's just basically, you know, imagine O's here. This O point is here, and I want to find that. So if I just draw this over here, it's not a right angle, by the way. It's not a right angle, but say I wanted to find this vector here. It's just basically going to be A1 minus A2. So it'll be A1 minus A2. And of course, remember, we're talking about distance, so we take the magnitude of this here. And so we get this overall, we've got this distance over here. Now we know that distance, we can, you know how this is our hypotenuse, this is our opposite, and this is our adjacent. We can actually use, because we have the adjacent and hypotenuse, we can use our cosine. We know that cosine theta is what? Adjacent, which is distance, over that. A1 minus A2. Yep. And so what we can do is make distance the subject. So it'll be A1 minus A2 times cosine theta. Yep. Now, you know, it's really hard because we don't know what theta is, but we can make it more simpler. Because if you don't know, what about if I just substitute another expression here? Like the magnitude of the distance unit vector. You might be like, Niels, why would you put that randomly there? Because it doesn't actually matter. Because remember, this is a unit vector. And in a unit vector, if you find the magnitude of a unit vector, it's always 1. So it was just, you can just put it in there. Because it's just, imagine, it doesn't affect it. But why do we put it there? Because it's very useful. If you don't know, what does this expression look like? It's actually our scalar product. Where, remember, A dot B is equal to the magnitude of A times the magnitude of B times cosine theta. Can you see how it looks the same? We have the cosine theta here. We have a magnitude of a variable. We have a magnitude for another variable. And then hence we can write them like this. So that means I can rub all this garbage out and write it nicely like this. Write it in terms of that. So it'll be A1 minus A2 dot, of course, your distance. So distance unit vector. That's it. Look how easy. We made so much progress. Now, okay, we're making progress, but we need to find the unit vector distance. Like, we need to find this. That's how do we do that? Like that unit, the distance unit vector. Well, coming back to this distance, if we can find that, we need to find the vector of the distance first, yeah? Well, if you actually don't realize it, because we know that this distance here is actually perpendicular to line, you know, this line over here, L2, and also the line L1, if you actually look at it, like if you put it right over there, it's actually also, if you put that line right here, it's also perpendicular to that. Because it's both perpendicular to those lines, we can find the cross products to find actual what the vector, you know, the vector D is. So we know that vector D is just the cross product. So it doesn't matter, like, let's say A2 times A1. No, what am I doing? Sorry. D1. So let's call this, so this one here, the directional vector, let's call it D2. And this one here, D1. Those directional vectors. So it'll be basically like, think of it, D2 times D1. So this is the cross product, and that will give me our D. Now that's beautiful. Look at how much progress we've made. Now, of course, we need to find a unit vector, and you remember how to find a unit vector. It's just 1 over the magnitude of this, which is the magnitude of that. So we can say the magnitude of D2 times D1 times the vector, this. D2 times D1. All right? And then basically just rub this out and just put it on top here. Beautiful. Look at that. Now what we can do is we can, before we even do that, just be careful. This is distance. Just remember, this is distance. So this, we have to take the magnitude of this, because you remember how the scalar product can be also negative? So we need to be careful. We need to take the magnitude because we're actually dealing with distance. So just make sure that you take the magnitude of that. And so we can actually substitute, you know how that is our unit vector? This part here is our unit vector of D. We can substitute that into that. Here. Take this over here. I'm going to write it. Let me just write it. Put that down here. So it's D2 times D1 over d2 times d1 magnitude that, and overall magnitude. That is your formula to find the distance, the shortest actual distance between screw lines. I remember looking at it for the Cambridge book. It's really hard to kind of visualize, because I don't know how they draw it, but I hope that makes sense. How we can just basically look at, I hope this kind of just simplifies your understanding of where we get this distance formula. And I think this one's much more easier. And yeah, normally don't do all this work. When you're in the exam, don't make all this garbage, like do all these working out to make up the formula. Don't do that. Just memorize the formula. You don't have enough time. Just make sure you memorize this formula over here, or you can memorize the easy one, which is basically just this part over here that substitutes into that. And I hope that makes sense. I hope this video just kind of simplifies your understanding of where we get the distance between screw lines. Alright, so coming back, we're coming back here. Let's finish this question off. So remember that the distance is what is the the modulus of course, your A2 minus A1, the dot product of your your unit vector of course your D, your that distance, but we write it as this now. So we would write it as this. So it'll be, let me write it nicely. It'll be D1 times D2 all over the modulus times D2. So I've already memorized this formula, but just it's such a pain. Okay, there it is. To see it was the last question. All right, there it is. So let's go. Well, it's really easy because we know straight away. So think of this as, this is your A1. This is your D1. This is your A2. This is your D2. Done. So we can put all this. So first, the most easiest to find A2 minus A1. Let's do that. All right, so it'll be 2i minus k minus A1, which is I plus mk, which gives you 2i minus k minus I minus mk, which will give you I plus, we can say, -1 minus mk. A little bit nice and simplified. So that is your, let me rub that out. That is your, this over here. I want to write it nicely. That's your A2 minus A1, which is I plus -1 minus mk. Done. Now what I'm going to do is I want to find now the cross product of D1 and D2. So D1 times D2 is, just remember this. So it'll be I here, it'll be J, it'll be K. So what's D1? So we know D1's 1, 2, 1, and D2 is -1, 3, 2. So coming back to the formula sheet, to find the cross product, it is, where is it? Come on. There it is. Okay. It's y1 times z1, so first one. So y1 times y1 times z2, which is basically 4, minus y2 z1. So y2 z1, which is -3, I plus x2 z1. So x2 z1, which is -1, minus x1 z1. So x1 z2, which is 2. Now, I'm doing everything right, yeah? Yeah, that looks good. I just want to make sure I'm not making any mistakes. Plus, then it'll be x1, y2. x1, y2, which is 3, minus x2, y1. x2, y1, which is -2. Okay, done. All right. So that'll be simplifying that. That will. I'm just trying to make sure if I made any mistake, because I think I was doing it 2, 1, 2, 1, -1, 3, 2, and then. All right. That looks typical. Okay, that looks good. That looks good. So 4 minus 3 is just I. That'll be -3j here. That'll be plus 5k here. Okay, so that is your d1 times d2, and of course we also need to find the magnitude of that, which is what square root of 1, 9, 25, which is root 35. Beautiful. So putting this all in that formula, the magnitude. First, let's multiply these. Yeah, let's multiply them. The dot product, so it'll be your I plus -1 minus mk dot your actual I minus 3j plus 5k, and don't forget that overall you multiply that by root 35. So that dot product is 1 times 1, it's just 1. And then you multiply the k, so it'll be plus 5 -1 minus m all over root 35. And that's, yeah, so that simplifies to what? 1 -5 minus 5m all over root 35. Oh my god, this is so like -4 basically. Okay, so we've got that, and don't forget the modules. We will have to modularize it. So -4 minus 5, and remember the modulus. To get rid of the modulus, you can do this. You can you can replace them with a plus or a negative. So you can take them out, but you can replace them with a plus or a negative. So we get actually two solutions. What's the, so it's equals 14 over root 35. So actually, first of all, just cancel these ones because the denominators are equal. And so you get 2, remember, you get 2 of these. So of course you get let's do the positive one first. That's that first one. And then let's do the negative one, which is this one over here. So we got 2 answers for this one. So the first, it will be what for the first one? It will be -4 minus 14 equals 5m, which is -18 on 5m. That's the first one. Then this one over here will be 5m equals 10, m equals 2. So m equals 2 and m equals -18 over 5. That's it. Wow, that is so much work. All right, and that's it. I hope you guys enjoyed this video. I hope you learned something through this video. Good luck with your special studies. Have a great day, guys. Bye-bye.